So, a quick agenda. I'll introduce myself. I'll take some time to talk about air traffic control and how we operate, what we do, and what networking is all about at our site. What networks we have? We have a lot, and what applications we run, and how we actually manage that running 24/7. So that's because we are a safety organization, a important thing. So I will talk about evolution versus revolution. At our side, it's more evolution instead of changing everything at once, revolution. And I'll tell you a little about what we're up to in the next steps in our systems. So myself, I'm a network engineer. I'm 1.5 years at LVNL. Before that, I come from a hardware background. Did systems, software, and now moving in the networking. I really love the lower parts of the stack. And in my spare time, I'm chairman of the board of the NLNOG. I do some ham radio photography and try to keep track of everything that's going on around that. So after air traffic control in the Netherlands, I got more than 1,000 colleagues, and that's not just the people that are in the control tower at Schiphol Airport, but it's also people that work at the other regional airports. And there's a lot of people that work in our radar center at Schiphol East, so not in the tower. Of those 1,000 people, there's 250 actually air traffic controllers. So there are either people that sit at the tower and guide planes on the field, or work at behind the radar screen in our radar center. So what do? We make sure that 71 million passengers at Schiphol Airport get to their destination safely. And that's a total of about 500,000 flights at Schiphol and another 614,000 flights 488,000 flights in 22. You see there the corona thing going on. That is transit. So we also control the flights that fly over Dutch airspace, for example, to land at London Heathrow or something, some other fields. So where are we? We're at Schiphol at 3 locations. So the 2 control towers at Schiphol, and we have the radar center at Schiphol East, and we also have people at all orange locations, which are the civil airfields in the Netherlands. We have people in the tower there, and people maintaining the infrastructure over there. And right now we are in a program to also incorporate the military fields into one air traffic control environment. So how does this look inside? So on the left side you see the screens at Schiphol Oost, the headquarters where the radar operators are, and of course we have the tower. This is the Schiphol Center Tower, where you have the view of the complete field. What you see is there that it's all electronic. So there's no paper involved. In the early days, they had these little wooden pieces with strips of paper where they wrote the call sign of the airplane, and then they had that stacked physically. Now, in the tower, they use an iPad or a big touchscreen for that. So we control the local traffic from the tower on the field. We have approach control that's arrivals and departure. For example, if a plane wants to land at Schiphol then and comes from the south and the just south of the border approach takes it over from radar control and guides the plane to actually in front of the runway. And we have area control, which is planes that are in the upper airspace, and for example, landing at in England or so, that they fly over our airspace. And then there's above that, all traffic is handled by the European Eurocontrol from Brussels control center for the layers above that. But actually, to do that, we need some networking because we have all those screens. And what do we do? What's the main thing? We need to be sure that planes do not crash into each other. That's the bottom line, right? That's our job, and we need to do that by trying to separate planes. Like in the horizontal plane, we need to have them 5 nautical miles, that's 10 kilometers apart. That's for the upper part of area control, and when they come into the field just in front of the runway, then the limits are 3 miles. But also, they need to be separated vertically. So that's 300 meters, 1,000 foot. Like in air traffic control, everything is non-metric. So that's the thing. So how do we do that? We can't see the planes. Like if they're up in the airspace, there's only a radar that we have when they like take off and land and are on the runway. We can see them from the tower, but everything beyond that, it's radar. And the other thing is, so we need a radar image, and we need to have a way of talking to the plane, talking to the crew, and that's the most important thing, to actually tell them by voice what the air traffic controller wants the plane to do. The air traffic controller is like the boss. The plane does not see other planes, so the pilot has to rely on the air traffic controller that he or she tells him, like to fly a certain route, or fly a certain height, or fly a certain speed, not touching the other plane. Because if you have 2 planes like flying 500 miles an hour and they are 5 nautical miles apart, it just takes 18 seconds to like collide. So it's a tricky thing. You got some time, but it's not that it's all an easy thing. And for and the important thing is the planes can't see each other. The radar controller sees them all on the screen and has that picture. So to get that picture, to get that radar picture, we need to have the data from remote sites, from radars, into the control center. So there's a whole lot of networking behind that. And to be sure that it always works, like 24/7, we need 24/7 systems running, and we can't like have either no radar image or no voice comms, because that's also going through the network. We have a three-lane principle in the in the complete systems. We have primary systems, the systems that normally work, the traffic controller uses. We have then backup systems, and they are constantly online, so there's just a single switch from one system to the other system. And then if those fail, like if we suffer a really big big outage, then we also we have last resort systems, and they're actually also in a physically different location. So they're not in the same building. So if that plane lands not on a runway, but a couple of miles either east or west, and there's no radar room anymore, we have last resort systems on a different location. And to zoom in a little more, our critical systems are connected to two networks. So we have two networks carrying the same data, and they're connected they're both connected to a system, and the application running on that system serves the redundancy. So what we have is the air traffic control system gets radar data from two sources, and it's up to the control system to actually use one source or the other source and detect whether one source is not available. So those networks, well, great, but what does run on those networks? Well, of course, we have systems for air traffic control itself, and we have systems for the pilots, like systems on the ground that the pilots use for either navigation to get in front of the runway, like the instrument landing system. And of course, well, the systems we use to actually see where the plane is and what the plane is doing. That's mostly radar. We have multiple radar sources coming through the networks to our data center, be combined, put data with that radar picture and put it on the screen of the air traffic controller. Next to that, we saw that we also need some means of communication to the plane. There's voice to the airplane and back, but also voice ground to ground, because that one controller that handles that plane flying over the Netherlands and wanting to land in like London Heathrow needs to hand it off to the controller in England, the center in England. So he can calling up and say, hey, this plane is I got it still on a certain height, and you expect it on a lower height, so that's coming. And a lot goes by network communication, but also a voice communications comes in very handy sometimes. So there's a voice communication system that in one press of a button you get the controller in like England or Brussels, or a Eurocontrol for the upper layers. Next to that we have the other information that the controller needs is like the flight plan. Where does this plane come from? What waypoints is it gonna take to actually fly into Schiphol? All that is coming from Eurocontrol Brussels over networking. We need to know what the current meteorological situation is on the field. Like the Dutch Meteorological Association has sensors on the airfields, like for wind, for temperature, wind direction, wind speed. Everything is fed into a system and presented to the air traffic controller, so he can tell to the pilot, hey, there's a crosswind, or also swapping runways. We have multiple runways at Schiphol, and when the wind direction changes, runways have to be swapped. So planes have to guide to a different route. Of course, we have monitoring control of all our systems, not only the server systems, but also the complete network. And from all beacons and auxiliary systems that help the pilots navigate and help the pilots line up to the runway. We have networks to that. And how does that look then? Getting in a little more technical. Like, we have all big colored balls are networks within our environment. So if a asset that can be like a radio transmitter or a radio receiver or a direction finder wants to talk to the on the right side the system that produces that image on the screen, then it goes through a number of different networks. We have local networks at the Schiphol or region fields that are connected with the network called Mustang through to the local network at the main site at Schiphol Oost. And also we have external network connections to like adjacent centers or like the flight plan database at Eurocontrol and whatnot. And of course we have the auxiliary networks that supports the rest of the non-ops people, the office automation and that kind of stuff. So we have networks on and around the airfields, rings. At Schiphol, we have a number of rings along the runways that connect the sensors to the network. We have a nationwide transport network that gets the data into Schiphol. We have the internal network at Schiphol, and we have a fairly big firewall environment that's in front of that. How does that look in some other nice picture? Like we have networks all over the place on all fields that are connected to the main site. So there's a lot of networking going on, a lot, a very complex environment. Well, there is some history. And because we are in the aviation field, there's slow development on systems. For example, an instrument landing environment with the antennas in front of the runway is has a lifetime of 30 years. So each and every 30 years, you swap that. Instead of every 4 years, you put in new switches and that kind of stuff. So, and with that, it is super reliable. So we want to have 100% uptime because we are in a safety critical organization. Yeah, because of that, we are not in an IP only environment, still systems that we run and have to communicate over the network use serial RS-232 interfaces, E1 interfaces, and that we need to slowly move while the plane is flying in mid-air because we cannot have downtime. So we have there issues of redundant stuff. We have complete. We have environments that are not yet redundant, and how do you migrate that in midair? So we have challenges in technology. Older technology, 30 years ago, needs to work with a newer technology that you buy now or that you bought 5 years ago. And we have two completely separated environments. We have a production environment that's operational, and we have a development, test, acceptance, and education environment that's not in the operational thing. And the way that you can run changes is completely different from the non-ops and the ops. Because the ops, you're touching the live systems with the live data, and if you pull a plug and you pull the wrong plug, there's no radio screen. And we saw that that might be tricky then. How do we do that? We in a transition of all sorts of networks, more than 400 different networks that are built and maintained by the different product groups. The radar group had their own network, their own service, their own network people. The surveillance group had their own network people, and that was interconnected. And we like to move to a network as a service thing, where we have one network platform or multiple network platforms that are interconnected, and that the radar can be connected to that, and I showed you before. So we need to standardize, and that's standardize on platforms, and we try to do that in an agile way, moving from the temporary workarounds. Hey, I got this set up this way, and hey, I got this set up this way, and now it needs to talk to each other into that air traffic control environment. So that's what we do, and yeah, standardization while integrating 400 plus legacy networks, and also supporting new stuff, because there's also new developments in, I want to use this, I want to use that technology, stuff goes on. In changing environments, there's a lot of regulations in our business, and they change. So then you have to cope with that and adapt your systems according that. And of course, there's changes in enhancing safety. When something happens, when we have an issue occur, then we need to learn from that, change our stuff, change the procedures, but also maybe change the hardware, change the environment to be continuously safe. And 24/7. So it's backed by regulations, procedures, and keeping it constantly running. It's no use, there's no option of saying, hey, like the next 2 weeks, we need to do some big upgrades, and like, yeah, this first week, close the airspace, and then we slowly ramp up. That's a no-no. So that's a challenge. How do we do that? Well, by challenging work, interesting things, talking to a lot of stakeholders, designing resilient environments, designing redundant environments, talking to the people that are working behind the screen or in the tower. What do they need? What can they? What room is there for time stuff to upgrade, stuff to change, and of course, new developments, because in 2026 we will be having a completely new air traffic control system. So the heart of it, the stuff that drives the radar screen. So we are together with the German air traffic control, a Spanish contractor is building a completely new environment for us. And currently we are in different phases of testing because it has to be tested, verified, checked against regulations, tested. Every tiny change has to go through that whole thing. We completely built a new building for that, like 10 years ago when this project started. And this project is, well, this is not to be proud of. It's on the top 5 list of projects in the Netherlands that the government is running with a lot of money. So that we are doing. So that's part of that is new networks, changes in networks. What we also are looking into is having the towers at the remote fields replaced by cameras, brought those camera images over the network to Schiphol, have the tower controllers there. And what also is very important is, because we do our own education, because there is no school for air traffic controllers, we have simulators to do the educational part. That's part of the simulators that we have at Schiphol. They need to be supported too, and they need to be fed with data. And last but not least, we want to, well, there's a program to integrate also the military air traffic control into our organization and also into our infrastructure. So a lot of stuff going on. I think I'm completely running over time, but maybe there's a quick question. One? There's 35 seconds, I see.
I'm wondering, Rudi, if there is a question from the room, go ahead, but I'm wondering, an organization like yours where the network has to be up 24/7, it's in a sense comparable to an ISP network that many of us have here, which also needs to be up and running 24/7. But I have a feeling that in your organization, the word change is regarded even more dangerously than in ours. Is there something you can say about that?
Yeah, well, it's all a matter of risk, and the risk aversiveness in our organization is maybe a little bigger than in the ISP. So yeah, everybody has that in their mind, but also one needs to work within that framework.
We have time for a few short questions because we are stealing the time from Bert, so that's not something you want to do. Boudewijn, go ahead.
Sorry.
Okay. We are all a fan of multiple redundant systems. Many of us are less a fan of actually testing out a failover to the redundancy. Have you done that to that one or the last resort system ever?
Yes. Of course, we need to, and we need to prove that. But we have for each and every system, we have a test environment where we can test stuff out and then move it to production. But before moving to production, failover tests have to be done and have to be shown that things work. And actually, sometimes the practice demands that we do a failover test in operation.
Right.
It just works.
Nick, go ahead.
Thank you. I have a bit of a technical question, if that's okay. I was wondering if the information from the radar systems, I can imagine that is ADSB. Is that done by software-defined radio and then transported via an IP stack to the people that actually need to read the radar, or is that more of an analog system or some other kind of system?
Well, the radars themselves are just analog sender and the receivers, and they're at different locations, and they're just the moving radars. Then the signal is digitally processed, and then this digital signal is transported over the network to the system where a radar image of a large environment is being comprised, because there's multiple radar sources. And next to radar, we also use multilateration, like different receivers that receive the broadcasts of the airplanes and then calculate in time difference where that airplane is. And that's mainly for ground operations. We use that at the Schiphol airport a lot.
Okay, cool. Thank you very much.
All right. Go ahead.
You mentioned about sending two streams of data simultaneously to the application for redundancy. So how does this application cope with it? Doesn't it has a high PPS? Do you have like DPDK, or does it have hardware accelerated? And do you put your voice traffic also there? But does it introduce any latency? Does it work well?
Yeah, it's dependent on the application. Like the application gets two data streams, and one application just chooses that data stream, the other application chooses the other data stream. But those data streams need to be the same.
So it has to pick one. It doesn't get the same and picks the right one or the correct one. It doesn't do correct.
Last question, Andrew.
Yeah. So you were talking about moving from multiple hacks to platforms, from multiple different disparate systems. But in that move, you would also inevitably lose some of the diversity, which also to an extent brings up some resiliency. So how do you tackle that?
For example, the complete, we have the different air traffic control systems. The main backup and last resort are different systems, different code base, different environments. So it's completely like separated. So a last slide, well, you can help us. And there's a website, kom werken bij LVNL. So if you want to we need some good artists, we need some good network engineers. So come talk to me, or it's fun.
Wonderful. Thank you, Rudi.